to Educator.com. In previous lessons, we talked about determinants. Today, we're going to apply determinants in order to solve systems of equations and solve for variables. And we're going to do that using what's called Cramer's rule. Cramer's rule shows us a way to solve for systems of equations, and we can do that in 2 variables or 3 variables. Today, we're going to start out with 2 variables, and then we'll go on in a minute and talk about systems of equations in 3 variables. Now, one thing to notice before we even delve into this is that this is broken down into this formula for x and another one for y. And what makes this rule helpful is that you may be in a situation where you just need to find one variable. You have 2 or 3 variables in your system, but you only need one variable. So instead of solving the entire system, you can just hone in on the variable that you're looking for. Okay, so looking at this, if we have a system of equations, ax plus by equals e, and the second equation, cx plus dy equals f, we can find x by using determinants. Let's first look at the determinant in the denominator. And I'm going to call that determinant, let's look at x, and I'm going to call this determinant d. Looking at y, it's actually the same determinant. And this is comprised of the coefficients of x in this row and the coefficients of y in this row. So whether you're looking for x or y, it doesn't matter. The denominator is going to be the same, and it's going to be a determinant that is comprised of, in this first column is coefficients of x, and then here, coefficients of y in the second column. Okay, now let's look at the numerator, and these are different. And I'm going to call the numerator for x d, and it's determinant for x. And here I'm going to have d and the subscript y to indicate that it's for looking for the y. Okay, now if you look here, you'll see that the second column, where I had the y coefficients, are the same. But if I'm looking for x, I'm actually going to replace the column where I had the x coefficients, coefficients of x, with the constants that are on the right side of the equation. Now look over here at y. This determinant for y, I kept the x coefficients the same. They're in their place. But where I had the y coefficients in that column, I replaced those with the constants. So I just think of this first column as the x column, the second column is the y column. And if I'm looking for x, I replace the x column with the constants. If I'm looking for y, I replace the y column with the constants. And then I just need to solve. Okay, so using an example, let's say I have a system of equations 3x minus 5y equals 2. And negative 3x plus 2y equals negative 8. And from previous lessons, you know other ways to solve this. You know substitution. You could use elimination. But this is introducing another way that is useful in certain situations. So looking at this, if I would like to find x, first I'm going to find x. Now, this determinant in the denominator is going to consist of the coefficients of x in this first column, 3 and negative 3, and the coefficients of y in the second column, which is negative 5 and 2. Okay, so I've got the denominator, and now I need to find the numerator. Recall that in the numerator, if I'm looking for x, I'm going to replace the x column with the constants. Here that's 2 and negative 8. The y column, I'm just going to keep it as it is down there. Okay, Once I get this far, I just use my usual methods for finding a determinant. And remember that that is, if a determinant is A, B, C, D, second order determinant, I just need to find AD minus CB, BC. Okay. So I'm going to do that. So x equals 2 times 2 minus negative 8 times negative 5 over 3 times 2 minus negative 3 times negative 5. Okay. Therefore, x equals, that's 4 minus negative 8 times negative 5 is 40. In the denominator, 3 times 2 is 6. Minus negative 3 times negative 5, that gives me 15. Okay, so this gives me x equals 4 minus 40, which is negative 36, over 6 minus 15, which is negative 9. So my negatives cancel out, and I get, so negative 36 divided by negative 9 is simply 4. So x equals 4. If I wanted to solve for y, I would already have the determinant in the denominator. So if I wanted to solve for y, it would actually be even simpler because I already know that the denominator is the same. So I would just put 4 in here. Then I would find the determinant that I need in the numerator, and I would look over here and say, okay, my x column is the same. It's the same as in the denominator. It's 3 and negative 3. Y, I would replace with the constants 2 and negative 8. And then I would just go ahead and solve using AD minus BC for the determinant and divide by 4. Okay. This can also be used, Cramer's rule can be used to solve systems of equations in 3 variables. And although this looks pretty complicated, it's actually the same idea as we just covered. Looking in the denominator, this first column is the coefficients of x, just like we talked about with systems of 2 equations. This second column is coefficients of y, and the third is coefficients of z. And that is exactly the same whether you're looking for the variable x, y, or z. In the numerator, here you see that this is the same as below. Okay, coefficients of x. Here, this is what I think of as my x column. I think of this as my y column. And then here, my z column. I'm going to replace that with the constants, since I'm looking for z. If I'm looking for y, I'm going to replace this second column with the constants, j, k, and l. If I'm looking for x in the numerator, I replace that x column with the constants. So the denominator is always the same. In the numerator, these 2 columns are the same, but for x, this one's different. For y, this one's different. And for z, this one's different. Okay. For example, solving this system of equations using Cramer's rule. So this is in the form ax plus by equals some constant. I'm going to call it E. Here, I'm going to call this Cx plus dy equals f. And then just remind you that if I'm looking for x or y, what I'm going to do. In the denominator, I'm going to have a determinant that consists of AC, coefficients of x, in the first column, BD, coefficients of y, in the second column. And that's going to be the same for both. In the numerator, I'm going to replace this first column with the constants. The second column will remain the same, coefficients of y. Here, the x column still will have the coefficients of x, but the second column where the y coefficients were, I'm going to replace that with the constants EF. Therefore, if I'm solving for x, let's start out with the denominator. So the denominator is going to be, coefficient of x is 1. The other coefficient of x is 3. Coefficient of y is -2, and the other is 1. In the numerator, I'm going to keep the y section the same. I'm going to replace x with the constants 1 and 2, the x coefficients. Now, I'm just going to recall that in order to find the second order determinant here, it's going to be, if this is a, b, c, d, it's going to be a, d minus bc. Therefore, x equals, this is going to be 1 times 1 minus -2 times 2 over 1 times 1 minus -2 times 3. Therefore, x equals 1 minus -2 times 2 is -4 over 1 minus -2 times 3 is -6. X equals 1. A negative and a negative gives me a positive. Same here. Negative and a negative gives me a positive. So x equals 5/7. Okay. Solving for y is actually going to be easier, because recall that these determinants are the same. The denominator is the same for x and y. Well, I already did all this work finding the denominator, which is 7. So I'm not going to repeat that. I'm just going to get rid of this and write 7 here. In the numerator, in this first column, I'm going to have my coefficients of x, 1 and 3, just like I did in the denominator. However, in the second column, I'm going to replace it with the constants, 1 and 2. Again, using my formula AD minus BC to find this determinant, that's going to give me 1 times 2 minus 3 times 1. Okay, all over 7. So it's y equals 2 minus 3 over 7. So y equals -1/7. So x equals 5/7. Y equals -1/7. And I was able to figure that out using Cramer's rule, where the denominator is the determinant formed by the coefficients of x and the coefficients of y. And the numerator is, the first column consists of the constants, the second is coefficients of y. Once I did that, y was easier to find because I already had the denominator. I just plugged that in right here. For the numerator, I had a determinant consisting of the coefficients of x, and then in the second column, the constants. Okay. Again, solving a system of equations with two variables. For x, okay, recall that in the denominator, I'm going to have, this first column is going to be coefficients of x, the second is going to be the coefficients of y. In the numerator, I'm going to leave the y's alone, but I'm going to replace x with 8 and 4, constants, 8 and 4. Now, I'm going to use my rule, AD minus BC, assuming that this is the setup, to find these determinants. X equals 8 times D minus B times C. Okay. Therefore, x equals 8 times 3 is 24 minus -16, or x equals 24, negative and a negative, that is plus 16. So 24 and 16 is 40. X equals 40 in the numerator over this denominator. Okay, so let's find the denominator. Okay, so the denominator determinant is 3 times 3. So that's the numerator for x. Now, to find the denominator, this is just the numerator. The denominator, I have 3 times 3 minus negative 4 times 2. So 3 times 3 is 9. And in the denominator, I have negative 4 times 2, so that's negative 8. And then this is going to give me 9. Negative and negative is a positive. 9 plus 8 equals 17. So this is my numerator right here. And I have my denominator, my x denominator right here. And this is going to give me x equals 40 over 17. Okay, so I found my determinants that this consists of the x coefficients and the y coefficients. This one is the constants and the y coefficients. And then I found the numerator right here. I found the denominator right here. And then I went ahead and put those together, and then x equals 40 over 17. Okay, now finding y. Finding y is going to be easier because here I have my denominator, which is 17. Same denominator, so that takes a lot of work out of it. In the numerator, in that first column, go the x coefficients. I replace the second column with the constants. And then I go ahead and find this determinant, which is going to be 3 times 4 minus 8 times 2. Okay, this is going to give me 12 minus 16 over 17. And that is going to be 12 minus 16 is negative 4 over 17. So here I have x is 40 over 17, y is negative 4 over 17, using Cramer's rule. Okay. Now, looking at a system of equations with 3 variables, and I'm being asked only to solve for x. And this shows you how this rule can be useful because I only have to focus in on that and not solve the entire system. You use the same general approach as with 3 variables. Okay. So I'm going to take x, and in the denominator, I'm going to say, okay, first column is the x's, the x coefficients. Coefficient here is 1, 2, 1. Y column, negative 2, 1. There's no y here, so it's just 0. Coefficient 0. Z, no z at this first one, so that's going to be 0, 1, 1. All right, now I'm looking for x. The first column represents the x coefficients. I'm going to hold on to that thought for a second, and I'm just going to copy over the other 2 columns because I'm not messing with those. I'm going to replace this first column with the constants, 3, 1, 3. Okay. Now that I've set this up, I've got to find a third order determinant in the numerator and the denominator. And you recall that we went over a couple of methods to do that, expansion of the minors and the diagonal method. And I'm going to actually use the diagonal method. The first step of the diagonal method is to copy over the first 2 columns. So up here, 3, 1, 3, negative 2, 1, 0. Here, 1, 2, 1. Negative 2, 1, 0. Okay. Once I've done that, then I need to start at the upper left and go along the diagonals. And I'm going to find, actually, right along this way, finding the product of that and adding the product of this diagonal to the product of the next diagonal to the product of the next diagonal. Okay, so x equals first product. This is 3 times 1 times 1 plus negative 2 times 1 times 3 plus 0 times 1 times 0. Okay, I've taken care of those diagonals. Now I start at the lower left and go along those diagonals. And I'm going to subtract those products. So minus 3 times 1 times 0. Next, 0, 1, 3. Minus 0, 1 times 3. Minus the last diagonal. And that is 1 times 1 times negative 2. Okay, that takes care of the numerator. In the denominator, I'm going to start at the upper left. My first diagonal is 1 times 1 times 1. And I'm going to add that to the next diagonal. Negative 2 times 1 times 1. Adding that to this diagonal. 0 times 2 times 0. Now, subtracting, starting down here. 1, 1, 0. 1 times 1 times 0. Subtracting 0 times 1 times 1. And then finally subtracting 1 times 2 times negative 2. Running out of room. Okay. 1 times 2 times negative 2. Okay. Working this out. Therefore, x equals 3. And this is negative 2 times 1 times 3 gives me negative 6 plus 0 minus 0 minus 0. 1 times 1 times negative 2, so that's minus negative 2. Okay, in the denominator. 1's multiplied, give me 1. Plus negative 2 times 1 is negative 2 times 1. So negative 2 times 1 times 1, that's negative 2. Plus, this is going to come out to 0. Minus 1 times 1 times 0. Minus 0 times 1 times 1, that's another 0. Minus 1 times 2 times negative 2. Okay, let's clean this up. This is 3 minus 6. Get rid of all these zeros. And this is minus negative 2. And that's the same as plus 2. In the denominator, I have 1 minus 2. Get rid of all the zeros. And this is minus negative 2. Actually, that's 2 times negative 2. This should be negative 4. Minus negative 4 gives me plus 4. Okay. Now, x equals, well, 3 minus 6 plus 2 is going to give me negative 1. In the denominator, I have 1 minus 2, that's negative 1, plus 4, that's going to give me 3. So x is negative 1/3. And as you can see, once you get it set up, then it's a matter of just keeping track of all that multiplication and these signs. So I set this up by forming determinants with coefficients of x, y, and z in the denominator. In the numerator, coefficients of y and z, and then the constants in the first row. Then I solved this by using the diagonal method, and I did that right here to come up with x equals negative 1/3. Okay, again asked to solve a system of 3 equations. So I'm going to start out by looking for x and looking at the denominator. For the denominator, I'm going to use the coefficients of x, 2, negative 6, and 4. The coefficients of y, negative 3, 9, negative 1. And the coefficients of z, 1, negative 3, 1. Okay, in the numerator, I'm looking for x, so I'm going to keep the y and z columns just as they were. And I'm going to go over here to the x area, and I'm going to substitute the constants 4, 11, and 10. Now, I'm going to again use the diagonal method, and I'm actually going to start with the denominator, and you'll see why in a minute, why you should always start with the denominator and how it can save you work. So I need to find this third order determinant, and I'm going to use the diagonal method. So I'm going to rewrite these first two columns, 2, negative 6, 4, negative 3, 9, negative 1. Okay. After I've done that, just going ahead and rewriting this. So I'm not working with the numerator yet. I'm just going to leave that like this. And I'm only finding this determinant in the denominator. Starting at the upper left, using the diagonal method, this is going to give me, I'm going to find the products of this first diagonal. That's 2 times 9 times 1 plus this next number right here. Next set of numbers, -3, -3, 4, that product, plus, coming down right here, 1, -6, -1. Okay. Then from that, I'm going to start subtracting this other set of diagonals, starting down here and going up. 4, 9, 1. The product 4 times 9 times 1. Continuing on, minus -1, -3, and 2. Minus this last diagonal right here, 1, -6, -3. Okay, so x equals, same determinant. Let's just work with the denominator right now. 2 times 9 times 1 is 18, plus -3 times -3 is 9 times 4, that's 36. -6 and 1, that's 6. Okay, and now subtracting 4 times 9 times 1, that's 36. Minus -1 and -3 is 3 times 2 is 6. Minus 1 times -6 is -6 times -3 is 18. Now, you can see what's happening here, that x equals this determinant in the numerator, but I have 18 and 18, so those cancel. That gives me 0. I have 36 and 36, so those cancel. 0. 6 and 6, those cancel. So I've got a 0 in the denominator, and that is not allowed. Since that is not defined, what I've ended up with is a situation where Cramer's rule does not work. It doesn't mean that there's not necessarily a solution to the system of equations, but what it means is that there's no unique solution. It may be that there's an infinite number of solutions. It's a dependent system. It may mean that there is no solution. But I can't go any farther, and I can't use Cramer's rule in this situation. And that's why the first thing you should do if you're using Cramer's rule is to check out the denominator and make sure that it's not 0. If the determinant in the denominator, d, is 0, you can't use this method. And that concludes this session of Educator.com on Cramer's rule. I'll see you next lesson.